All right, welcome back, solo miners. We built the poor man Avalon Q in the last video, and now we need to tune it. So we're gonna leave it into the hands of AI to tune this miner to find out how hard we can push it and what our limits are, while trying to keep it somewhat efficient. So before we hop onto the computer, there's just two things. In an effort to achieve the most that we can, I did two mods. One, I modded the PSU, which I'll show a quick video of me doing here. And that was because there's a PDF out there that says that if you put a resistor on the APW3, which is somewhere over there, it will actually increase the voltage from 12.5 to 14. So I did that so we can have a bigger area to test. Additionally, I went ahead and changed the paste on the board with some thermal grizzly paste and some MX5, just because if it's cooler, we have more area to push it. So why not? And finally, before we go hop to the computer, please do subscribe if you haven't. We're almost to 1,000 subscribers. It would mean a lot. Let's go ahead and jump to the computer and start tuning the poor man's Avalon Q.
Right. So here we have LuxOS open. We have our poor man's Avalon Q running. So for those who haven't experimented with LuxOS at all, so right here, of course, you have your terahash running, and if you want to adjust the frequency, all you have to do is come over here and you click on custom profile. So creating a custom profile is fairly easy to do. You create a custom profile, enter in test 43. I mean, you can name it anything. So this voltage, let me actually back up here. So that voltage will depend on what you have here. If you set it up to be, like, for example, if I set this to 12.5 and I go and create a custom profile of my volts being 14.2, it doesn't matter. It will lie to you and say that, it's going at 14.2, but it's not going at 14.2. It'll be going at this bypass voltage. Additionally, if you have a 12.5 volt PSU, so like the mod that we did, and you set this to a higher number, um, it most it'll let you set it to that higher number, and if you come back to the dashboard, it'll show the voltage as that higher number, but you're not actually getting that higher number. And what happens as a result, just like when you had bitaxe gammas, or if you mess around with bitaxe gammas, you would see that error percentage. You would see a high unhealthy chip rate here, and you just won't get the terahashes you're hoping to get. So if we go back to preset profiles, you want to keep that in mind where your voltage is. So most of you, if you didn't do any modifications or do that resistor mod, which is totally fine, we're going to test and see if that's worth it or not. You're going to have a voltage of 12.5 or lower. So you're able to underclock this to whatever, you feel is good. And then for frequency, just like the bitaxe gammas, this can be, usually you want to start at like 300, 490. You want to start lower and then go higher, just because of temperature and stuff. But like right now, I'm running at 360, I believe, frequency. But yeah, you can go through this, and to do this manually, it would take a lot, right? Like if we wanted to do, all right, let's do 12.4 and then run at 350. You click save and apply, and then it takes about like 5-6 minutes for it to warm up, and then that would kind of give you your hash rate. So what happens when you do this, if we apply a custom profile, I have some here. So these are the ones I've created so far, but you can tell if a profile is bad once I click on one of these. Like, see, this one isn't great, but because we have two chips that are unhealthy right now, that means that most likely we would want to choose a different profile, because ideally you're aiming to find a profile where all your chips are healthy, 100% healthy. And so this has 2 unhealthy chips, which isn't bad because like some of the profiles, if I went up to 400 frequency, we would see like potentially maybe 8 or 7 unhealthy chips. And the other thing is too, it's once you do it, it's not instant. Like the bitaxe gammas, it was like 1 or 2 minutes. With this, you're looking at about like 10 minutes for everything to settle. Um, yeah, so just know if you see unhealthy chips, doesn't mean that your board's bad. Essentially, that means you just need to underclock and find the right combination so you have 100% healthy chips. But you know, 3 unhealthy chips, and we're doing about 40 terahashes, 41 ish. That's not bad. Um, I may have to turn the fans up because I have my power off temperature wise. As where is it? It's temperature presets. So these are my. This doesn't really matter since our fans are in manual mode. So this could be whatever. But my board hot temp is 74 and 75. I have this higher because since we're not running all 3 boards and I know it's in a cooler environment, I know it can handle these temperatures. And most likely it will not hit those unless I have a really bad frequency set where it just spikes up to that. So I'm not too concerned with the higher temperatures. And then chip temps, these I believe are default. I didn't change these. And so pretty much what happens if you have a bad config as well is it'll spike to that temperature and it'll just shut off. You'll still be able to see the miner in LuxOS, but your board won't be available. And if that does happen, all you have to do is go up here and click restart Lux Miner, and then it'll restart it. So going back to the tuning, as we can see, if I went and created a custom profile and tested this, so this will take forever. So what we're going to do instead is we're going to take our handy dandy Claude Code and create us a script. All right, so currently we're having Claude AI, build us a script that will tune our miner, which is running on LuxOS. It uses API endpoints, and the best way I could do this so it's somewhat showable in the video is I'm going to have a yeah, go ahead and do that. Just run everything. No, I'm kidding. But I know what's doing here. So what we're going to have is a low limit of 300 frequency, and then the end limit will be about 440 frequency, and we'll start at a voltage of 11.8 and go up to 13. It'll step by 0.35 each time. So it'll go from 11.8 voltage, go to 12.1, and then from 12.1, it'll go over to plus zero point 0.3, which is 12.4. It'll consistently do that. But while it does like 11.8, it'll go to, let's see what it says. We'll test passed. Run a test with the miner. So this is our IP. So let's go ahead and so it'll, while this runs, it will just test it, just like how you have those bitaxe gammas, and you can auto tune them by doing a 11.8 around 300 frequency, test results after 10 minutes. Let's see what the results are. Go to 11.8 voltage and then go up to frequency of 320. And it'll just slowly step like that. Find the best voltage combination pair that's the most efficient, and then it'll come back again, and wherever range was most efficient, it'll then step by 1 frequency and then keep going to find the best frequency combination. I set a hard limit of 72 degrees because I don't want anything higher than that. Usually when it gets up to 72 degrees, that means it's going to overheat because it's just too much for the board to handle. And I set a max wattage of 1200 watts. So with that, we probably won't get the most terahashes we can achieve, but we want to get the most efficiency. So yeah, I just typed all that in Claude, and I had it generate the script This is better than saying, "Hey Claude, I have a miner at this IP address. Go run the max frequency," because what it'll do is it'll create this, but sure, it'll create this, but it'll burn all your tokens. For people who don't know what tokens are with AI, that's how much you can use in a week is your tokens. Additionally, I made sure if anything above uh, for um, I think it was 6 unhealthy chips in a after 8 minutes of running, it will discard that config and move on to the next one because we can deal with 1 or 2 unhealthy chips, but more than 6, you're gonna be losing more hash rate, so we don't want to do that. So let's see what it's doing. Okay, so it's working with the temperature sensor right now because I think the temperature readings are off. So we'll let AI do its thing. It's sending commands towards the miner and coming back with the data and reading it, and then creating our script and doing that magic on its own. Um, and so we'll just let it keep on cooking, and then we'll see here. I have my fans set to about I think it's 80% right now, just so we can see what it does. I probably should set up to 90 or 100, but I ideally want it to run at 80%. And you can't really hear them right now, so I think it's fine. But I'll let this continue to run, and then we'll come back once it's ready to our full script to run. All right, so AI has finally built everything. It was correctly able to see the hash rate, the temperature, and the unhealthy chips right now at our current config of 340. I think it's 12.5 volts, but because I have this in my setting as 13, it's showing as 13. Um, but it was able to get, unhealthy chips 0, which this means is a good config, and total chips running 108. So that's good. So we're going to go ahead and have Claude run our full test. We have our IP here, 132. Um, Side note, I will have the script available for anyone who wants to run it. You don't need Claude AI. This is just because we're developing it right now. But what you would do instead would be Python 3, the name of the script, host, IP, which is what we have here in our address bar, and then how much your settings. We want to step by zero point 0.3 voltage, and frequency we want to step by 35. And then this will go through, step by this amount, and then find the most efficient pair, and then in that that range, it'll go ahead and do a smaller fine tune step. So, but because we have Claude and we're running it, let's go ahead and have it be an agent and monitor the results. So for this, we're going to go run a full sweep at this IP and click enter. And I know this will burn a lot of tokens, but this will also let it run with input, and it'll monitor it in a sense so we can go more hands off. So this will take about um, 4 or 5 hours to run. So I'm going to let it do its thing, and then we'll come back with the results to see what was the most efficient run and what we landed on. So I'll see you guys in a little bit. Quick little update. So I asked it, we're part way through our test. We're at 12.55. So this only really matters if we did the voltage mod like I did, right? Because 12.5 is the default stock PSU. That's what it goes up to. So anything below, everyone else can do. Anything above, you need the low resistor mod that I did. And so far, asking, what the trend is it worth going past 12.5? Claude AI told me, the trend's going the wrong way, right? Because at 12.55, it just seems like it's burning watts and not achieving a better terahash hash. So it advised me to, to kill it and just do, what did it say? It said the highest hash, use one of these settings in a sense. The most efficient is so far 12.10, and frequency of 300. So instead of doing that, I said kill this setup right now, this test that we have. There's no point of going past 12.5. So that's our hard stop. But instead, I saw some promising results, at least in this table. I saw some promising results at 11.8. And this, because you can always go down further. So let's instead run a test at 11.6, going from frequency of 300 to 400. Because if it can perform really well at 11.8, who knows if 11.6 with a higher frequency will give us a better terahash, because that's pretty good right there, even exhaust wise. So it's currently running that right now. It's doing the test, and as you can see, the frequency has dropped down to 300, and we'll see how this goes. So one final update will be done once we finally get the results and see what the best combination is. So I'll see you guys in a little bit. So the script has finally finished running. And if we go over, where is my VS Code? We go over here. I had asked it just pretty much give me a summary of the data. So actually, before we do this, let's go ahead and review the CSV because it did generate a CSV. So if we go over to here, so in the folder that the script ran, there was a CSV right here. And oh my gosh, come on. Okay, let me zoom out a little bit more. So in this CSV, there's gonna be everything that I tested, right? And this is a lot of valuable information, especially for your miner, because it'll tell you what the voltage was set, the frequency set, the duration of the test, number of samples, and then the hash rate achieved, watts achieved, joules per terahash, standard deviation. Not sure what I would do with that, but exhaust temp, chip temp, and other information. And so this is really helpful for making decisions whether you want to go, where's our terahash hash rate? If you want to do a max setup of a lot of watts, I guess this isn't too bad, 869 watts for 44 terahashes. Or if you want a more efficient setup where you filter by joules per terahash, wherever that is. I swear I saw that somewhere. Right here, joules per terahash, like 16.89. 37 terahashes for 637 watts isn't bad. And so this can help you make a decision when instead going the manual method that we went with LuxOS, manually creating profiles and testing and stepping up that voltage with each combination pair. So to expedite this, because I haven't looked at the results myself, I asked Claude AI to pretty much summarize our results for us. So we had 16 aborted because the temperature just got too hot. And when it gets too hot, it will just shut itself down. We have this temperature set at 72 degrees. I showed that earlier. And then we had 46 tests that were able to complete. So our best efficient setups have been these so far. So we get 36 terahashes for 604 watts, achieving 16.61 joules per terahash, and 11.8. So that's interesting. Okay, so and this goes back to what I had previously said as well. The additional test I did with 11.6 doesn't seem to be on here, so it seems like there is a certain range where once it drops below that range, it won't be efficient at all, and it'll actually not achieve good results. And I'm sure that's recorded in our CSV as well. But and then the best terahash setup was apparently 45 terahashes with 11.8 volts and 360 frequency, and that achieved a pretty good joules per terahash. And then it gives you some more information here about just a summary of where it started to shut down, because once it shuts down once at like 405 frequency at 11.95 volts, it's not going to go to the full length of the test, which is up to, we defined at 440. It would just stop there because anything above it's just going to keep on shutting down. And yeah, this kind of just says that what we lower voltage achieve the highest stable frequency, likely because lower voltage generates less heat per cycle. Okay, 12.4. Okay, cool. So I am going to do, does this talk about the 405? All right, so I'm going to say, go ahead. I'm not sure if this is possible at all, but let's apply the most um, efficient profile to our miner. So we're going to say create a profile and apply the settings to the miner for the most where is this? Oh, I'm messing my spelling. Efficient efficient combination. Should do combo. Create profile and apply the settings to the miner for the most efficient combo. So technically it should be able to take what we gave it, which is the I think it's this 12.1 and 300 frequency, and apply it to the miner. Let's see if it does that. But in the meanwhile, that for me, I am personally going to run the most efficient setup rather than maximizing the hash, just because it is summer here and it is starting to get a bit hot. So if I run the most terahashes, like that 45 terahashes, there's a higher chance, because we have that manual gauge on our fans, that I have to babysit it and make sure it goes to 100 or go down to 80. It's not super loud at all by any means, but I'd rather have my stuff going quiet, um, especially because this is my workspace that I have all the miners set up at. Uh, let's see. Oh, it doesn't know my IP. Okay, let's see. Where do I? Can I do tab? Nope. Let's chat about this. I'll type it below. Is 192.168.1.132. I think that's what it was. 132, yeah. I can't stress this enough. Wait, press up to edit queued message. Hold on. Escape. Yeah, okay. I think that went through. I can't stress this enough that this is very useful, especially if you're using the poor man's Avalon Q, you're using a Loki build, or any other, bitaxe gamma nerd QX++, and you don't want to sit there and manually do the work. The AI will help you do that, and it will go ahead and interact with your miner and find the most efficient setup. So let's see, it's at 375. We'll see if it jumps down. Yeah, I'm not sure what's happening here, but I'll go ahead and cancel this. I'll just not be lazy and apply it myself. I'm sure it is possible to apply those profiles, but we'll just do it here. So this will be good to show too of the manual method. So we'll say AI profile -2 low power. And, oh, geez, if I could spell. And then that was 12.1, I think. 12.1. And where is my VS Code? It was most efficient. 12.1 at 300 frequency. Save and apply. And then if we give this a couple minutes here. All right. So I went ahead and applied that. I waited a couple minutes just because that it usually takes that long for it to apply and get all the chips up to date. So we have not chips up to date, the chips up to the frequency. So we only have one unhealthy chip, which is expected. That's just how it goes. Some combinations allow for zero, and some combinations have a couple. But this is still pretty good. If I have an app on my phone, which shows me the wattage at the wall. So 725 watts, that's pretty good for 37 terahashes. I usually do, before the setup, it was 860 watts for 40 terahashes. So this is more efficient. So this is probably the setup I'll do, especially since it is summer's coming up. And this way, I'm also able to turn down the fans a lot too. I can turn down 50%, and it's like whisper quiet, and it keeps the board at 60 degrees. This is another big thing. You want to keep the temperature somewhere in like the 55 to 63 range, because that's when it performs the best. Too cold and your hash rate will actually drop too. Yeah, it's kind of crazy, but the if it's in that sweet spot of 60 to 70 degrees, it performs really well. So just FYI. But that's gonna be it for this video. I appreciate you guys tuning in. Please subscribe if you haven't already. I have some more cool builds on the way. I believe it's another miner that we're going to build. Instead of relying so much on 3D printing, we're going to use the original chassis, and hook it up to Wi-Fi, and we're going to try to build it. I want to say under like $320. So that's coming soon. That's probably my next build. So watch out for that. And yeah, I'll see you guys in the next video.